Hello and welcome to AT&T Cabling Systems series of presentation. We are going to talk about selecting the right cabling system for POE application in this presentation. My name is Taif Shakir. I am the technical manager for AT&T Cabling Systems handling Middle East and Africa. In this presentation, we are going to talk about what is the POE, what are the POE basics. Then we are going to talk about components consideration of horizontal cabling. And we are going to talk about DC resistance imbalance and the impact of DC resistance imbalance on the POE and the applications standards itself. Then we are going to move to component consideration and cables, connectors. Then POE plus safety and grounding issues. In part 2 of this presentation, we are going to talk about AT&T Cabling Systems product that supports POE. We are going to discuss horizontal cabling and indoor RJ45 and shielded Cat6a jacks. Part 1. POE Basics and Standards. At the beginning, let us define what is POE. POE stands for Power over Ethernet. It is a standard that describes a system which safely transfers electrical power along the data to remote devices over standard twisted pair LAN cables in an Ethernet network. Power is injected by power sourcing equipment or PSE, which is typically POE-enabled switch or mid-span power supply device. Then the data may be any Ethernet protocol ranging from 10 base T up to 10G base T, and it shouldn't be affected by the power delivered on the very same pairs used for data transfer. The power devices may be voice over IP phones, wireless access points, clocks, sensors, cameras, light panels, any device that need power. Let us have a look on POE Basics. On the right hand, you can see there are two configurations of POE. The top one is using POE network switch, and the POE device will get the power through the Ethernet cable, while the other option is using something called mid-span. There should be POE injector, and the non-POE network switch is connected to this POE injector, and the POE injector will inject data and power on Ethernet cable to the POE device. Let us have a look at the types of POE. We have, according to IEEE, 4 types of POE. Type 1, which can deliver up to 350 milliampere per pair. Type 2 can deliver 600 milliampere. Type 3 will deliver the same 600 milliampere, but will use 4 pairs instead of 2 pairs that used in type 1 and type 2. While type 4, which is what is known as POE++, it is delivering 960 milliampere for each pair. And you can see from the table the power required at the PSE. It is varied from 15.4 watt on type 1, 30 watt on type 2, 60 watt and 99 watt or almost 100 watt on type 3 and type 4. All of those are standardized by IEEE and the standard codes are shown. There are non-IEEE standards such as Cisco UPOE or Cisco UPOE Plus or HD-based where you can go for 60 and 90 and 100 watt for each of them. The common thing between non-standard or non-IEEE standard is they are using all the 4 pairs to be energized. There are many challenges when we are going to supply DC power over a LAN cabling systems. In this presentation, we are going to talk about passive network only and not going to talk about any active challenges. The major problem caused by PoE is the heat generated due to the electrical current. As you know from Ohm's law, the watt or the power, it is the multiplication of ampere multiplied by volt. Since the voltage is limited for safety reason, most of the time it is below 60 volt, the only parameter which can be increased in order to increase the power is the current. Unfortunately, at the same time, if we go back to Ohm's law, the power generated, it is I square multiplied by resistance. So the higher current, that means the higher power generated by the conductors or the higher heat at temperature. Higher conductor temperature means we are getting higher DC resistance. Higher DC resistance means we are getting higher insertion loss and higher heat generated. So it is a loop or a cycle. We would like to have a low current and low DCR, but both are increased, turning the heat dissipation of the cable to be a major issue. As we saw from previous slides, the current flow in the PoE channel, it is a major factor determining the PoE effectiveness. The first thing we are going to discuss in the component of PoE channel is horizontal cables. There is a term called cable ampacity. The cable ampacity depends on the amount of heat generated and the amount of heat dissipated. The cable ampacity can be affected by multiple factors. There are the cable design factors and there are installation factors. The cable design factors, it is the conductor size, the metal content and the cable construction, and the insulation jacket material size for formatting and temperature rating. Those are related to the cable design itself. Then we have something related to the installation, the bundle size and the bundle formation, open tray or closed conduit, the tray itself, the tray material, if it's metal or plastic, the ambient temperature and airflow around the cable. Due to complexity and the interrelation between those factors, it is impossible to predict what is the real ampacity of each conductor. But we can provide general guidelines about what is the best cable can be selected. Another important parameter for PoE support is the DCR imbalance between the two wires in each pair and between the pairs itself. The DC resistance imbalance of any pair is the difference in DC resistance between the two wires in each pair and is the difference between the DC resistance for the all four pairs. Why it is very important to monitor it and know what is it, we are going to discuss this in the next slide. But let us look at the major contributor in the DC resistance imbalance uh, is the poor plug crimping and the inconstant jack termination. For example, you can see on the right top figure the way of terminating the copper conductor into the IDC. If this termination point was not properly done, we might have DC resistance imbalance at this point. So one of the reasons is not using a multi punch down tools. We in AT&T cabling systems provide such tool in order to unify the termination of the pairs. The cable DC resistance imbalance is usually not that big a problem because it's already monitored and during the manufacturing. But it should be tested by the manufacturer as well. The perfect cable balance cannot provide a guarantee for perfect link or channel DC resistance imbalance. So each and every link or channel must be also tested for DC resistance imbalance. The DC resistance imbalance limit are set by IEEE 802.380 clause 33.2.7 at 3% of the total loop resistance. Similarly, ISO IEC 11801, they set the exact same limits. You can see here in the comparison between TIA and ISO standard, the limits inside each pair should be maximum of 3% of DCR imbalance. The DCR difference is 0.1 ohm maximum. The channel limits inside each pair specified for all categories should be 3% maximum as well, and the DC resistance difference is 0.20 ohm maximum for the channel. In the channel, we are expecting more DC resistance imbalance because of the modular code that terminated or used crimped plugs. So what is the DCRU impact on POE? When a DC current doesn't split evenly between each conductor of the twisted pair, the Ethernet transformers at both the PSE and the PD side of the link develop small DC bias current across their primary coils. It is shown on the graph here. Much like an electromagnet or a solenoid, this DC bias produces a magnetic field that compresses or limits the magnetic transformers coupling available to AC signal, such as 10 or 100 or 1000 base T or even 10G base T signals across the conductors pairs. Therefore, as the I bias increases or the current increases, the transformer core starts to saturate. This resulting in a nonlinear compression or distortion of Ethernet signals, as well as attenuated low frequency performance and reduce magnetic coil inductance. In simple terms, high levels of DCRU may cause degradation of Ethernet applications. Therefore, it is very important to have proper DCRU values for cabling systems. Now we are going to talk about the standards which are ruling the PoE. First one is TIA TSB-184A, which is published in March 2017. This is giving a guidelines for supporting power delivery over balanced twisted pair cabling. It contains configurations, structure and topology of PoE, cable selection and performance, installation guidelines, DC resistance, which is very important, and then remote powering configurations and related transmission parameters. There are annexes addressed cabling types and installation guidelines for DC powering modules and measurement methods. In addition, the well-known TIA 568.2-D is going to have addendum, which is addendum 2, as requested by TIA TR-42. In this, there will be proposal for providing normative requirement for supporting the delivery for power over Ethernet installations of balanced copper cabling. This is intended to supplement the material which is already set by TIA TSB-148-A. Such document will clear things up and enable designers and installers to have better confidence on the future performance of the cabling when running PoE applications. In addition to TIA standards, there is ISO IEC TS 29125, which is published in April 2017. This standard is information technology telecommunication cables requirement for remote powering of terminal equipment. These documents describe methods to help manage temperature rise and keep cables below their maximum temperature rating. Environmental conditions of installed cabling, including bundle cabling and cabling in conduit, heat dissipation profiles of different categories and type of cables, and how these conditions and profiles might impact the capability of telecommunications cabling to support the PoE application. Several issues to align TS 29125 with TIA TSB-184A were agreed, but there are substantial differences. The main difference is ISO IEC 29125 recommends that the model size shouldn't exceed 24 cables for a new installation, as well as the routing and selection of pathways should be optimized to improve heat dissipation. This is very conservative and safe approach, while TIA is more permissive. In addition, there is Senelic EN 50174-2. This is published in June 2018. Actually, this standard is not related to PoE because this is talking about cabling installation, part 2, installation planning and practices inside buildings. But this will talk about the recommendation of how to maximize the airflow between the cable bundles. Actually, this one is very useful when we are going to have PoE applications. As discussed before, The major concern in PoE is the temperature rise in the cable. Therefore, TSB-184A includes tables of the expected temperature rise as a function of the conductor size or the AWG size of the cable conductor and the bundle size in different currents in open air and inside conduits at 20 centigrade ambient temperature when all four pairs are energized. This is the table here shown, the number of cables versus the temperature rise in centigrade at 600 milliampere current per pair. And you can see that the lowest conductor size, which is 26 AWG, having higher temperature rise when we increase the bundles, while the 23 AWG category 8 having a less temperature rise than the small conductor. In addition, you can see clearly that the cables which are inside the conduit will be affected more by temperature elevation in comparison with the cables are left only in the air. Therefore, TSB recommends to avoid any temperature rise above 15 centigrade in steady state. This is a graphic representation for the previous table, and we can see clearly that whenever we have bigger conductor, whenever we are getting better performance or lesser heat generated by the cables, and therefore we can have more and more cables in one bundle. For example, from the graph, we can say clearly that we can put 90 pair or 90 cable in one bundle when we are using Cat 6A 23 AWG. But it is not the same when we are using 26 AWG. The maximum is around 32 or 30 cables only. Always remember, ISO and IEC limits the number of the cables per bundle as 24 only. TIA TSB-184A did the same experiment but with 1000 milliampere current per pair, and here the values are increased from the previous table. We are going to see the graphic representation of this table in the next slide. You can see from the graph here, when we use 1000 milliampere, the total number of cables in one bundle is decreased. For example, 26 AWG decreased to 15 cable per bundle, and the category 6A is up to 70 cable per bundle, and category 6 is up to 50 or 54. Always remember, ISO and IEC TS 29125 limits the number of cables per bundle up to 24 cable maximum. On the right hand, you can see the typical test setup of heat dissipation when only one cable placed in the center is energized. So if we are going to use TIA TSB-184A, we have to look at few recommendations of using this. TIA recommendations are based on practical average values obtained from different vendors based on different numbers of energized pair in different bundles. Users should bear in mind that different cables from different vendors may have substantially different heat dissipation due to different cable designs, materials, metal content, and more. For example, AT&T Cat8 SFTP cables made with 22 AWG conductors provide lower temperature rise than indicated in the TSB-184A. In addition, there are many cables that like UUTP, UFTP, FUTP, FFTP, SFTP. Those cable constructions and the material contains have substantial effect on heat dissipation. Those differences are not highlighted in TSB 184A. TIA-TSB recommendations specify maximum bundle size in 20 centigrade and in 40 centigrade. Users should bear in mind what is the ambient temperature of the cabling that installed, because it might be substantially different um, in different seasons or different areas of the world, especially when it is installed under rooftop or in location where the heated air is conveyed. In addition, designers should bear in mind the auto catalytic effect when cables are overheated. There is addendum 1 to this TIA TSB-184, which is talking about 24 or 28 IWG code that used in POE delivery. We have been talking about the cables, the number of bundles recommended by the standard. Now we are going to talk about another component in the channel, which are the connectors. In addition to problems related to overheating, RJ45 connectors are exposed to a physical damage when running POE applications. Let us go through the problems that can be affecting the POE delivery in RJ45 connectors. The opacity, according to UL1863, for RJ45 connectors is confirmed up to 2.2 ampere. This is enough to support all POE types, including type 4. The DC resistance unbalance pair to pair and within the pair in the connectors itself, it is important as well, but has very limited impact on the channel DCR imbalance compared to horizontal cable or the termination methods. The major concern is the mechanical damage caused to the gold-plated contacts due to the spark created when disconnecting the modular cord under load. The amount of damage may be reduced by proper design of the contact strips inside the RJ45 and the amount and the quality of the gold plating itself. You can see from the pictures, we have 4 pictures. The one on the left showing the new unused contact. The one just after it showing contact after mechanical cycling under no POE load, while the next picture showing contact origin caused by a single arc during unmating under POE load. After a long time, you can find the status of the connector as shown in the right picture. As shown in previous slide, The pictures was clearly showing the corrosion happened due to unmatting the RJ45 connector and plug while PoE is active. Therefore, we have to think in a way to design the RJ45 jack in such a way the contact area during the data transmission should be different than the contact area during the discharge. So even if the gold plating is damaged in the discharge area, the contact DC resistance should not be affected. You can see from the pictures where is the discharge area located in the right picture, while the normal contact area for data and PoE is seated just far away from that point. If the gold layer is totally removed, the inner metals, which are mostly copper, may start to corrode with time, and this will cause disconnection of the signal and disconnection of the PoE delivery. Some damage to the contact is unavoidable, but the worst damage occurs outside the fixed contact area if the jacket is properly designed. IEC 6512-99-002 is used to assess the amount of damage caused by those disconnections. Therefore, it is highly recommended to specify Cat6A jacks that are tested and officially verified according to this standard. You can see on the right hand picture the compliance for AT&T cabling systems Cat6A shielded jacks that are verified to Delta and tested according IEC 6512-99-002. After talking about cable requirement and connector requirement for PoE, we are going to talk about PoE safety and grounding issues. According to IEEE 802.3, it's required that all PoE equipment shall conform to IEC 16950-1. In IEC 16950-1, this is the standard talking about information technology equipment safety part 1 general requirement. It has detailed definition and instructions for the requirements concerning the correct grounding and bounding of IT systems. The installers must be familiar with this standard and follow it in order to provide safe and trouble-free operation of the installed cabling, regardless of the cabling if it's shielded or unshielded. A general note, all POE applications generate something called SELV, safe extra low voltage, and as such cannot cause any harm to humans in any way. Grounding of power systems and PoE are totally different issues based on different standards. Mixing those two issues may cause confusing and may put users at risk. The relativity, the relatively low power delivered by PoE cannot cause cable melting and fire, but overheating the plastic ingredients may cause degradation in addition to the obvious insertion loss increase, which will adversely affect the transmission quality until shutdown. All PoE types work equally whether you are using shielded or unshielded cabling. The PoE power is always directed only into the pair conductors never to the cable shield. But always remember, the shielded cables is better for heat dissipation. Therefore, if you have many bundles, it is recommended to use the shielded cables. In part 2 of this presentation, we are going to talk about AT&T cabling systems, products, and compliance to POE applications. All AT&T copper line products are suitable for POE applications. AT&T copper line includes a wide range of copper cabling components supporting POE. Those are horizontal and backbone cables, flexible or stranded conductor cables, RJ45 plugs and jacks, RJ45 modular cords, and patch panels. AT&T copper line products are available in all present cabling categories. We have Cat 5A, Cat 6, Cat 6A, Cat 7, which we have only the cable, Cat 7A, only the cable, and 1200 megahertz cable, as well as Cat 8, 8.1, and 8.2 cables. All of those products are perfectly fit for POE applications. AT&T cabling systems provide a wide range of cables for both shielded and unshielded. We highly recommend shielded cables for POE applications. We have 4-pair UUTP, 4-pair FUTP, 4-pair SFUTP, F4-pair UFTP, 4-pair FFTP, and 4-pair SFTP. All of those are complied with POE standards, and the minimum ampacity for each pair is 1 ampere, which is more than enough and suitable for all types of POE, including POE Type 4 as well as non-IEEE standards protocols. AT&T Copperline Category 6A shielded jacks are officially certified by Delta EC in Denmark for compliance with multiple standards, as well as including POE plus matting and unmatting connectors under load. Certificates are shown in the pictures. We have talked about channel components that affect the POE delivery. We have talked about cables and connectors and how to select them properly. Now, another factor which is very important during implementing POE networks is the installation. Installer must make sure the installation is done in better quality. Using single pair termination tool or single pair impact tool is not recommended. We in AT&T cabling systems highly recommend to use 4-pair punch down tool that terminates and cuts all the 8 wires in one squeeze. This will provide an equivalent amount of force on all conductors and will minimize the DC resistance imbalance which may be caused by different DC contacts resistance. Summarize our presentation. IEEE 802.3 Type 3 and Type 4 POE standards is fully ratified since 2018. So many of those cabling systems installed today will most probably deliver 100 watt running 1 ampere currents per pair when all 4 pairs are energized. The major power limiting factor is the ampacity, affected by the DC resistance, which is affected by the heat dissipation from the conductors, which may become critical in large cable bundles. Following TIA TSB-184A guidelines, minimizing the chance of getting overheated cabling with all its consequences. User must bear in mind, however, that those recommendations are based on average results and are quite primitive compared to ISO IEC TS 29125, which is recommending 24 cable in a bundle as a limit. Shielded cables, or mainly SFTP cables, with larger conductors, 22 AWG, minimize the heat generated and maximize the heat dissipation. Based on TIA TSB-184A, 24 AWG SFTP cables, namely Cat7A and Cat8 cable, can be installed in bundles of 170 cables inside the closed conduit without passing the 15-degree temperature rise limit. All of those carrying 1 ampere per pair when all 4 pairs are energized, which is the typical case of type 4 POE. The LAN connecting hardware must not be damaged during disconnections. This can be verified according to IEC 60512-99-002. The resistance imbalance of LAN cabling system, which is affected mainly by jack punch down and cord plug crimping, must be kept low in order to ensure proper performance of both PoE transformers and minimize distortion of data. Thank you very much for your time. I hope this presentation was informative. My name is Taif Shakir. I am Technical Manager for AT&T Cabling Systems, handling Middle East and Africa. My contact email is presented at the beginning of this presentation. Please don't hesitate to contact me anytime. I'm ready to support. Thank you.